Topic 4, test review. These numbers 1 through 4 are kind of just overviews of topics that are going to help you throughout the review, so let's go through those. Number 1, it says, what are the 5 triangle congruence theorems? Yes, I know they're on the board, but they will not be tomorrow for the test. Okay, so what's one of them?
Side, side, side.
Side, side, side.
Side, angle, side.
Side, angle, side.
Angle, side. Angle, side, angle.
Angle, side, angle.
Angle, side.
Angle, angle, side, and then
Hypotenuse.
hypotenuse leg. Okay, so you want to know those for your test tomorrow because they will not be on the board. Number 2, it says draw 2 examples of when you can assume congruent parts of congruent triangles. And then the hint I gave you there was when triangles are connected. So there are 2 ways triangles can be connected. What's one?
Vertex.
By a vertex. Okay, so if I draw this picture here, they are connected by this vertex point. What else can we assume then since they're connected there? These 2 angles are congruent to each other. Good. Okay. What's another way they're connected?
Straight line.
A side, right? Yep. So we can say these 2 triangles are connected by that side. What can we say about this middle line? That it's congruent. It's the same. Yep. So those are 2 ways you can assume congruent parts for connected triangles. Okay. Number 3 says draw an isosceles and equilateral triangle, label the triangles, and list their properties. Okay. So let's start with isosceles. What do we know about isosceles triangles? Yeah, we know that 2 sides are the same, which means that 2 angles have to be the same. Remember, those angles are across from the congruent sides. Do we know anything else about isosceles triangles? No, that's it. Okay, now let's talk about equilateral. What do we know about an equilateral triangle? All sides are the same, which means all angles have to be the same. Do we know anything else about equilateral triangles? Yeah, all angles are 60 degrees. How do we know that? Why is that something we can assume?
Because 180 divided by 360.
Yeah, all of them add up to 180. So if I take 180 divided by the 3 angles that we have, we do get 60. Okay, so those are the properties you need to know about isosceles and equilateral triangles. Okay, and then last one here, number 4, says draw a right triangle and label all of the parts. What classifies a triangle to be a right triangle? 90-degree angle. Yep. So we have our 90-degree angle. What are the other important pieces? Yeah, it'd be the hypotenuse. What side is the hypotenuse? It is the longest. It's across from the 90. Yep. So this is the hypotenuse. What are the other 2 sides called? They are called legs. Yep, the 2 sides that are connected to that right angle, those are the legs of the right triangle. Okay, and that's all you need to know about the right triangle. Okay, so we have a right angle, we have our hypotenuse, and we have the 2 legs. Numbers 5 and 6. Number 5 wants us to find the measure of angle J first. So we can just focus on this triangle here. What do you notice about that triangle? It's an isosceles triangle. We knew that because we have 2 congruent sides. What else can I assume then? 2 congruent angles across from those 2 sides. Good. So using information that we have, we know this angle right here is 72. What's a good first step we can take to solve for this missing angle? Yep, we can take 180 minus 72, which is 108. What we just found is that these 2 angles together equal 108 degrees. How do I find one of them? Yep, take 108 divided by 2, which is 54. Okay. With questions that have multiple parts, okay, what I want you to do is go ahead and label it in your picture. So what we just found, this is 54, which means this angle is also 54. Okay, and then number 6 wants us to find the measure of angle M here. Okay, well, what do we know about this bottom triangle here? It's also isosceles because those 2 congruent sides, so we can assume what? Yep, 2 congruent angles. Is there anything else in there that we can assume? Yeah, how do you know this has to be 54?
Because the angles are congruent because of vertex.
Vertical angles, yep, connected by that vertex, so we know these have to be the same. Good. So now what's another step we can take to help us find that missing angle? Yep, 180 minus 54, which is 126. So what we found, both of these angles are 126. How do I find one of them? Divide by 2, which is 63. Let's hop up to number 7. Okay, number 7, making sure we read directions. It wants us to find all the missing angle measures. Okay, so what kind of triangle is part A? It is isosceles because of those two congruent sides, so what can we assume? Right, we can assume that H and G are congruent to each other, so yes, what does G have to be? 66. So we found one of them. How do I find this third one?
Those two up and one minus.
Yep, if I know 2 angles, I can find the third, so I'm going to add the 2 that I know. I get 132, and then how do I find the last one? 180 minus 132 is 48. Yep. So making sure you find all the missing angles that you do not know for this number 7. What about part B? What kind of triangle is that? Equilateral. Okay, we know that because of these congruent markings on all the sides. What can we then assume?
All of them are 60.
Right, we know all the angles have to be equal. Well, and we talked about this earlier, they all add up to 180. So I can just take 180 divided by 3 to give us 60. So we know all of these angles here have to be 60. Numbers 8 through 10 is using the same diagram. Notice we have a lot of overlapping triangles here. Okay, so let's look at number 8 first. It wants us to know if CDF, if it helps, outline. Okay, it wants to know if this triangle is congruent to this triangle here. Okay, when we're trying to figure out if triangles are congruent, remember we're using one of the 5 congruence theorems. Okay, so at these 2 triangles, which one of the 5 congruence theorems should we check first? Because has that right angle. Okay, so checking HL, do they have a congruent hypotenuse?
Yeah.
Yes. Do you agree it's this?
Yeah.
Okay, and this. So we're good with the hypotenuse. What about the leg? Yes. Do you agree that's here?
Yeah.
Okay, so we do have HL to satisfy the 2 triangles are congruent. Okay, the explanation part, this is your explanation. Okay, cool. Remember, it kind of helps to know past information. So yes, we said those 2 triangles are congruent to each other by HL. So what else can I assume then? Yeah, we can then assume like this side is congruent to this side here. Okay, that might help us out later. Number 9 wants us to prove this triangle is congruent to this triangle. We want to know if it is or not. Okay, which one should we check first? Hypotenuse leg. Does hypotenuse leg work? What's the reason some of you are shaking your head no? Right, these lines right here are our hypotenuse. Do we know anything about them?
No.
No. So HL doesn't work. Does that automatically mean the answer is no?
No.
No. Okay. Do those 2 triangles that I have overlapped, do they share anything? What do they share? Yeah, they share this whole side right here where they overlap. So we know this whole side is congruent to itself. Okay, now do we have enough information to say they're congruent to each other?
Yeah.
If so, what's the theorem there? What is it? It is side angle side. Yep. Because we have this side, this angle, and this side. Okay, awesome. Let's look at number 10. Now, know that you just proved the 2 major triangles in this picture are congruent to each other. So remember, you have those corresponding parts that you can use. Okay, so in number 10, it gives you some angle measures. I highly recommend you put them in the picture. Okay, so BEF, this angle right here, is 100 degrees. And CBE here, this angle is 75. It wants us to find DAG, this angle here. Now, just looking at this angle all by itself, do we know anything about that?
Nope.
No. But is there a corresponding part congruent to this angle on the other side?
Yeah.
Where?
See?
Yeah, it would be right here, right? Remember, we can assume that because we just proved the major triangles in this picture are the same. Okay, so remember, we can use corresponding parts to help us out here. So, knowing that, how can we help us find that missing angle measure here with this given information? Ideas. Notice that we have this triangle here, yeah? How many angles do you want to know to find the third? You want to know at least 2, right? Can I somehow find what this angle is? How?
CB is congruent. It's like 2 corresponding parts.
Yes, but I'm more looking at what do we know about these 2 angles right here? Does that make sense? They're not congruent, but if they're on a straight line, what do we know about those?
180.
Yeah, they add up to 180, right? So I can take 180 minus 100, which is 80. Yep.
So 155.
So what we just found is that this angle here is 80. Oh. So now, can I find that missing angle of the triangle? Okay, how?
75 plus 80 is 155.
75 plus 80 is 155.
Minus 155 is 25.
Yep, 180 minus 155 is 25. Good. Okay, any questions about 8 through 10? Okay, so remember stuff from last chapter and a couple chapters before, that can come back to help you. So if you have like angles on a straight line, no, they add up to 180 degrees. Go ahead and flip to the back page of your review. Numbers 11 through 13, they use the same diagram, but I want you to know they are their own problem. Okay, so let's go through this and tell you what I mean here. So number 11 says if BAC is congruent to DCA, so this angle congruent to this angle, is ABE, this triangle, congruent to CDE, this triangle?
Yes.
Well, what are some things we can assume first? They're connected here, right? So what can we assume about these two?
They're angles.
Their angles have to be equal. Okay, can we assume any other random information? No. But now, remember when we're proving triangles to be congruent, we want to use one of the 5 theorems. Yes, I know it is multiple choice, okay, but I highly recommend look at your picture and then choose your choice. Does that make sense? So what theorem matches that?
Angle, angle, side.
Angle, angle, side. So your correct answer is A on that one. Okay. Now, when you're moving on to number 12, you forget all the information you just learned in part 11. Okay, so I'm going to erase my picture. We're moving on to a whole new problem. Okay, so on number 12, it says if BD bisects AC and AC bisects BD. What does the term bisect mean? Yes, it means it crosses. Liam, what'd you say? It splits it in half. Yep. So these 2 lines right here get split into 2 equal parts. So I can assume that this half is congruent to this half, and this half is congruent to this half. Okay. So it wants to know if these 2 triangles are congruent to each other.
Yes.
What's the reasoning?
Side, side.
It is side, side, side. Did anybody say side, angle, side? Does side, angle, side also work? Why? Right, we still have these congruent angles here, so side, angle, side would also work. I would take either of those, okay? And then number 13 is the last one. Again, it's a whole new problem, so erase your picture and start over. So number 13, what does this symbol mean? What do those 2 lines mean?
Sideways.
Sideways equal. No. What? It does mean parallel. Yep. So it tells us AB is parallel to CD. Make yourself a little note there. This means parallel. What's a symbol I can put in the picture that signifies parallel? Arrows. Yep. Put 2 arrows there to tell you they are parallel. And then it wants you to know if these 2 triangles are congruent to each other. Okay. Well, let's talk here. Do those 2 triangles share anything? What do they share? They share this middle side, right? So I can mark that middle side. What do you think the reason was they told you that the 2 lines were parallel? Do you remember way back when what to assume when we have parallel lines?
There's an angle.
There is a congruent angle where?
Um,
What is it called?
the vertex.
Not a vertex. What about alternate interior angles? Remember that there? So we can assume this is our transversal through these two parallel lines. Okay, do you agree I could assume this angle is congruent to this angle?
Yeah.
Okay, because of that alternate interior. So what I want you to do here, okay, with this parallel, if you ever have this given to you, you are looking for alternate interior angles. Because what do we know about alternate interior angles? They are congruent to each other. Yep, so that's what you're going to look for. So now looking back at our picture up there, what theorem matches that? And again, if you struggle to see it, draw one of the triangles out. What we have marked right now is this. Side angle side. Yep, so what's the correct option there? C. Yep. Good. Is it okay to have an answer no? It is okay to have your answer be no, okay, if none of the theorems work out. Okay. Any questions on 11 through 13? Again, remembering they are their own separate problems using the same diagram. Okay. Let's take a look at number 14, your favorite, some of us, proofs. Okay, there will only be one proof on the test. Okay, one proof. What do we always start the proofs with? Given statements. How many given statements do I have?
2.
I have 2. Yep. So we know BF is congruent to DF. Reason? Given. What do I also want to do with that? Yep, make sure you mark it in the picture to help you out there. When you mark it, remember what you mark. We're talking about this whole side there. Okay. And then our second one is EF congruent to CF. What's the reasoning? Given. And again, mark that in your picture as well. What do we look for after the given statements? We look for whatever they have shared, right? So what's shared in this one?
Angle F.
Angle F. How do I write that as a statement?
Angle F equals angle F.
Angle F is congruent to angle F. Reasoning?
Shared angle.
By a shared angle. Yep. Okay. Yes, we're trying to prove these two angles to be congruent, but what do I have to prove after? Yep, after we have the given statements and our shared statement, we always want to prove the triangles to be congruent next. Okay, so my statement can be triangle BCF is congruent to triangle DEF. What's the reasoning?
Side angle side.
It is side angle side. Again, if you struggle to see that, draw it on the outside. What we have marked is this. So that one is side angle side. Now, can we prove our proof statement?
Yes.
Okay, one thing I want to talk about real quick. I noticed a lot of us are putting that as our statement. Okay, what should we put as our statement?
Angle B is congruent to angle D.
Yeah, we want the actual proof statement. So angle B is congruent to angle D. What's our reasoning?
Corresponding parts.
Corresponding parts. Okay, so remember, your proofs always kind of follow the same outline no matter what you're trying to prove. Okay, so you always want to start with your given statements. After given comes whatever they have shared. Okay, whenever you have the shared, that's when you can prove triangles to be congruent. Okay, and then as always, whenever you have this proven, you can prove the rest by corresponding parts. Okay? Let's go ahead and look at our last example here, number 15 through 18. We are using the same diagram here. One question that multiple people had last week is what this is pointing at. Okay, that's pointing at this very little angle on the inside. Okay, if it showed like the whole angle, it would probably have this marked for you, telling you that whole thing is 35. Okay, but it's just talking about that small angle on the inside. So number 15 wants to find angle TQR. So this missing angle here. Ideas. Right, we know two angles of that triangle, so we can find the third. So I can take 35 plus 25, which is 60. What do I want to do with 60? 180 minus 60 equals 120. I am not going to be picky about the explaining part, okay, but I just wanted this here today, so that we can talk about it. How did we know to do that? How did we know we can do that? All angles in a triangle add up to what? 180. Yep. The explaining like this is enough. Okay. When you find something, what should you do with that? Put it in the picture. Yep, mark it, because that could probably help you with the rest. So let's look at number 16. It wants to find the measure of angle PTQ. So we're looking for this very small angle in here. Okay, can I assume that the angle is just 35? I cannot. What can we do to kind of help us get there? Notice how we have a triangle right here.
Yeah, there's a 90-degree.
There is a 90-degree angle.
Yeah.
Can I find this angle right here?
Yes.
How? Yeah, it's on a straight line, right? So if we have a straight line, what do we know about these two?
They equal 180, so 180 minus 120.
Exactly.
So
Yep.
90 plus 60.
Yep, so I'm going to take 180 minus 120 first to give us 60. When you find it, put it in the picture. Okay, now I know 2. I can find the third. How do I do that?
90 plus 60.
90 plus 60.
180 minus 150 is 30.
Yep. I take 180 minus 150, 30. Again, so that's your number 16. Once you find it, what do you do with it? Mark it in the picture. Okay. Number 17. You guys can see that. I'm not going to move down because we need the diagram. But it wants us to find M and T. So this angle right here. Okay. Thoughts? Well, let's keep moving here. So yes, we're looking for this angle. Can I figure out anything about this triangle here? What? This is a 90-degree angle also. Okay, what else? What do you notice about this guy right here? What kind of triangle is that? Isosceles. So what can we say about this angle right here? 60.
So that means that one's
Right, if we did the same process we did, yes, this would also be 30. Okay, how can we find this guy right here?
It's on a straight line.
It's on a straight line, so yep, number 17, we can do what?
180 minus
180 minus 60 to get 120. Awesome. See how we kind of worked our way there?
Crack the code.
We did crack the code. So this is 120. I know it doesn't ask this, but what would this angle be right here?
25.
Why would that be 25?
Of course, or congruence.
You can say congruence, but what do you notice this whole big triangle is? It's an isosceles triangle, right? So we know these bottom two angles would have to be the same. Good.
That one on top is 35.
So the one on top would also be 35. Yep. On number 18, it asks for what is MR? What is that talking about?
The whole entire.
It's talking about a side, right? So it's talking about this side length here.
Yep.
Do we know anything about the side
Yeah,
length?
there's 4 and a 6.
Yeah, we know this length is 4, this length is 6, which doesn't make any sense, but they said that. Okay, so what I want to talk about, does this look like it can be 6 if this is 4? No. Okay, if the diagrams tell you, you can assume that that's true, even though it doesn't look like it. Okay, what did we kind of notice as we kept looking through these triangles?
There's 4.
Right, is there a lot of corresponding parts?
Yeah.
Yes, okay. So what would this side be right here? Would be 6. What side would this be? That side would be 4. So how do I find that whole side?
4 plus 6 plus 6 plus 4.
Yep, just add all of those together. What would my total length be? 20. Okay, so like we did on number 17, we kind of had to do or find some other parts before we could find that. Just remember that, okay? Any questions on 15 through 18 with that diagram? Okay, study tools. Let's talk about this. What are some things you can do?
Bonus extra.
Bonus IXLs. When are those due?
Tomorrow, grade 1.
Tomorrow at 3:20. So you have the whole day tomorrow to get those done. When is your test? Tomorrow. Notes from chapter 4. Okay, we took a lot of good notes this chapter, talking about definitions, the theorems, when to use them, all of the things. Okay, and there's good examples in your notes there. I'm gonna star this one, circle this one. Pay attention here real quick. Okay, look at your proof practice packet. Okay, the ones that we've done together. Okay, take those as practice. And then any homework that I have handed back to you is a good resource as well. Okay, what else is a very, very good resource? The review that we just did. Okay, so what I would do is your review, be your safety blanket for tonight, and your bonus IXLs. Those are all good ideas to go off of there. Yes?